So we're here to solve this LITS puzzle by Prasanna Seshadri. It's got a lot of these P-shaped pentomino regions, and so at the start I'm assuming a key fast step is to actually mark all of those in. And even when we have a snake-shaped region that's got 5 cells, the space where a lot of those cells are accounted for leads to some fast deductions. A key thing to always note, these P-shaped regions can be an L, an S, or a T. We actually have a situation where L and S both touch this shape, and so the only thing left is a T option. And those all come from recognizing one of these 3 cells in a shape is not used. If this isn't used, it's a T. If that's not used, it's an L. If this isn't used, it's an S. But there actually is no place for an I given the size of these groups. And another thing to note is even when these come close to another shape, there's also a way that the elimination from the 2x2 shadings will force certain things to be impossible. For instance, if this is shaded, you're forced to make an L because this cell, as you sort of mark these 2 in, these would be the first you'd shade, this gets unusable, that's an L. But at the same time, when you mark this in, you mark this not in, and so you put an L next to an L. And so one kind of tricky deduction at the start is to see that a cell like this can't be shaded because an L next to an L is unavoided. And so we make a new pentomino shape, which actually now forces an L up here. When this is an L, we need to shade in a cell like this and a cell like this so that these shapes now still have a T or S option, but they no longer have an L option. That actually also makes this shape up here another P pentomino shape. And this is a really gorgeous puzzle that we keep making subregions that are P pentominos. Again, I have to shade this so it's not an L shape. If I shaded everything but this cell, it would be L by L. But here we also have a case where this is 1 cell away from touching an S. Can't take this cell. That now means this shape can't take this if it would form a T next to a T, so this is an S. This now has an L and S next to it, so must be a T. And so these corners just resolve by some very careful LITS thinking. We can't shade all the way through this because of the 2x2 rule, so these cells are certainly not used. That's probably the most we can mark there right now. Even a region like this, which has 6 total cells, we know that these 2 are used in some group, and that will help us somewhat. The cell is not possible for a 2x2 region rule. If I shaded from here, I'd get 1, 2, 3, 4, but I'd complete a 2x2 square in doing so. So this cell isn't used, and so we get a little bit of constraint in the space. It looks like this cell is always shaded in every valid solution of the puzzle, that if this isn't shaded, we have to form a 2x2 right there. And we can think about what happens if we shade more cells nearby this to really start to constrain the full grid. One thing to again observe, we talked about how taking a cell like this near a P forms an L nearby, and that's still the case if this cell is shaded. We form an L right here. What you need to note is that you actually end up forming an L in this adjoining space. So right away you are going to cut off these 2 cells because of the 2x2 rule, and now you're left with a P pentomino, and you shaded all of the determining cells of that except for this one, which must be unused. And so an L goes by an L. And again, in this puzzle, a look-ahead step is you can't use a cell like this because you'd put an L by an L. We instead have to take these cells. That marks this as these 2 as not being used together, so the top part of this can't be shaded. The bottom of this now is fairly limited. If we shade all the way from here up, we would actually limit this cell and that cell. That's no good. So we're going to have some constraints up here. I can take one of these cells, not both, because of the 2x2 rule, so I must take this cell. That shades this one off. This then comes in. This can be an I or an L. It's going to be near to this shape, which is always an L, and so probably the Li is the one that looks most reasonable, but we'll have to think about how we get connection down to the side. So let's come back to this in a second, but maybe first let's see some of the implications as we think about these other shapes. We have this 2x3 box. It seems a little interesting, and it's pinned by these P pentominos. Let's come to this shape and say which cells in this must be shaded. This cell is in the center. of 7 total cells, so this is always shaded. And you can't shade an O shape, so this is always shaded. So we have this as a starting point. We now want to think about the limitations that are nearby the shape, and it looks like there's actually an L dance again even here. Let's think about this cell. If this cell is taken, regardless of which cells of these are taken, an L is going to be formed, but we also mark off these 2 cells as unusable, 2 by 2 rule, 2 by 2 rule, and so this forms an L. So a cell like this puts an L by an L, it's not possible. And so faster than you might expect, you can actually eliminate this down to be an S shape, this to be an L shape, and an S and L touching this form a T. This is now the 3rd triad we've seen. We saw one up here and one up there. We now form another P pentamino in the leftovers. It's not an L, so it's got to take this cell. And it's not going to be able to be a T because it's touching one and could be made to touch another. So this is an S. So we've got these shapes in the grid. This now is going to need to be completed as an L, S, or T. Let's think about a new kind of connection here. If this is an S shape, if both of these cells are taken, it looks like we force an S up above because we cancel out that. So this is not an S. That means it must take this cell. It'll take one of these. And we don't know for sure which right away, but it does look like there's a good opportunity to make progress from that side. I'm looking at connectivity right now just because that sometimes comes through in these puzzles at about this stage. And it looks like the center region's connectivity is going to be key. This cell needs to connect somewhere, and this cell needs to connect somewhere. And this cell actually has just one option for it. So these cells are shaded. Once these are shaded, this cell is no longer reachable. And so this is shaded. And that actually gets us a great start in the center. It's not a T next to another T. So this is done. We still need to connect through over here. So this cell must be shaded. That actually says that this and not this are shaded because we need to avoid an L next to another similar shape. We still need to get all of these things joined up, and recognizing that we can't come through this side and still connect through. This must connect in. That means that an L avoids another L. This L finally forms the I next to the L that I said might be needed earlier on. And so we finish this pirouette. It really has the same kind of logical step a whole lot around the grid. It focuses a ton on these P pentaminos, whether they're given at the start or form as you think through them. Different kinds of cells we looked at during the solve, which are really a kind of look-ahead logic that's key in LITS, where a placement somewhere will influence both a forced tetramino shape. So this cell, for instance, is always part of an L once we have these cells shaded. These cells were always parts of an L once they were shaded. But if knowing this would form an L means in an adjacent region you form the same tetramino, that actually excludes those cells from being used. And that kind of thinking got us through most of the puzzles. So if it's not a logical step you've used before, hopefully you learned in this grid and are set to use it for other puzzles this week and in LITS in general. We'll see you again soon.